So to reiterate on a few things, with flow tectonics, the primary movement is the crust emerges from the interior of the Earth, comes out the South Pole area, and then everything on the crust proceeds north to the South Pole area, the North Pole area, where it goes back in, obeying the laws of magnetic flow. That's the primary motion of the crust on Earth. You can see the subduction zones that basically surround the Pacific Plate, which primarily moves north. The reason why it does that, and it's the largest northern moving plate on Earth, and is surrounded by the major subduction zones, including the top main dive down area, in which material from the crust returns to the interior of the Earth, is because this is where the Eurasian continent and the Americas come back in. They emerge from the the Atlantic spread, where material comes out and flows this way, out and flows this way. So the second most movement on the Earth of material is east-west, spreading from this extrusion. And so as this comes up, eventually the pressure starts to build to where these emerge out of the sea and become land masses. As they move, this one moving west, that one moving east, the South American continent on its way up to the North American continent will probably start to look like the American continent. It comes up to about here, where it starts to shove over this way, which is why you have this big subduction here as it hits this plate region, and starts to move over this way. North America used to look like South America because they repeat as they emerge from the South Pole. And so South America is moving this way. Basically, when you say South America, you're looking at a larger region than just the emerged out of the sea landmass. And it moves over this way. The tail end of South America eventually will be twisted over. And if you just shoved this over and moved it up, you'd see how the tail would twist. But what's happening here is you're seeing as it's moving around this section. Who knows how many sections of sections could be up in the north, because that's where, if they aren't subducted, they tend to mass and just sit there, which is why some of the oldest rocks are in the world known are up here. So this moves here and starts to grind this way, and that's why you have so much turbulence in the Rocky Mountain Cascade area. Major zones like the San Andreas, that's just a straight shot where it's the Pacific Plate's moving north, and basically it's milling the North American plate as it's being shoved over this way. Just like over in Eurasia, as Africa moves over this way, up against this stationary mass and moves over this way. This Africa, which soon will become India, which is probably another one previously, or in a row. This all gets shoved over to here and trenched under. But again, as it's being pushed this way, the Pacific plate is milling the edges off, just and taking it in to the trenches where it cycles back through the center of the earth to the south and comes up. If it's not subducted from the Pacific, where basically with your subduction zones, a large amount of materials coming in here to come out on the other side, on the the Atlantic spread. So this may have been thinner at one time, but as it's moving north and milling the continents, pressing on it, or it tends to start to twirl on the edges and gather material. So if it was a little floating strip, as things were subducting here, it would slowly but surely gain material because it sticks to its edges as it's milling, and as the east and west Atlantic flows are pushing in on it. It just sticks to the sides and it gets bigger. Plus, it's got the circumference to fill up. But so if you want to look at the North American area here, there's Juan de Fuca, and the western North American plate comes this way, and the Pacific's coming up this way, and there's a section that's just kind of floating there, while this does dive in places, and this dives in places. And you got your straight shot here heading north, and then this is kind of like a void. So there's a lot of turbulence going here. There's a lot of floating pieces. The Juan de Fuca plate, they say, is older than here and here. And so it's just kind of sitting here floating. And that's what the Pacific plate does on the bigger scale, is it's sitting there floating. As it's moving north, it's also got the east and the west pushing in on it and diving under while it's sitting there floating, getting perhaps bigger, as the Juan de Fuca plate is also in between two subduction dives, and it can be getting larger also. It's kind of like a broken windshield up here. It's just kind of fractured up. The stretch marks are interesting to note. And so you've got the major movement moving north, the east and west pushing in on both sides of it. And of course you have Australia, New Zealand and all that. And this, it's just kind of, that's probably where Burma's coming from. Burma is probably old Australia. That would make sense. And you've got subduction zones where it's packing up against here, because if everything's moving to the north, then if it's not being subducted, there may be some downdrafts. Siberia's got a big downdraft. Iceland's a downdraft, and Yellowstone's a big one. Those are areas where the crust liquefies and dives down, but a lot of this stuff just sits up here. And so if you've got a mountain range that was born long a time ago down here on the tip of the South American tail, and it moves all the way up north, becoming the North American continent, and that continues to move all the way north. If it's not being shoved over and disappearing and subducting, if the last little remnants of that particular South America continues to make it up here, that mountain range is just going to get eroded down. Not only will it'll get eroded down so far there's not much left of it. So it's sitting up there with the heavier materials exposed now, since the lighter materials have all eroded away, and that's why you find lots of gold up there, is because it's an old mountain ranges. It's where old mountain ranges go to die if they're not being killed in the subduction zone. So interesting amount of materials and minerals there. Also, like the Appalachians and the Rockies, this probably was a sea all the way here at one time, but the Appalachians and the Rockies have eroded to sediment this. So as they erode, they're filling in the Gulf as they erode, and they have turned this from a shallow sea into the Great Plains as we know now. So it was a shallow sea and also a desert back when the Earth was younger. As the Earth got older and more mellow, it became the fertile breadbasket like other regions in the world. And but this was when the Earth was younger and all these volcanoes were going off. And with all this volcanic activity, you had an increased amount of carbon dioxide and other greenhouse gases. But the Earth is well able to handle such things. And here's one of the ways it does it. It melts all the ice, or as much ice as it needs for the hot party. And that ice turns into liquid water. So now it's in the weather system, the cooling system. And the oceans become less salty, which means they evaporate faster. And they turn into clouds, which make larger weather systems, which carry heat off the surface of the planet up into the coldness of space. So you got all the heat off the planet out into space, so it can carry as much heat as it needs to carry off. It used to carry off greater amounts in the prehistoric times than it ever has that we've seen today so far. Also, by heating up the planet, you have an increased, very, very, very large amount of heat gain on the planet surface, which makes it more plastic, which means this flow rate of the tectonic activity increases, which means you're going to have a lot more stuff moving a whole lot faster and larger moves worldwide. You're going to see activities like the Madrid Fault start moving again. People say, oh, it's old and extinct. No, that was back when things were moving faster. That was part of the plastic fluid dynamics of a flow. It's like hydrostatic. Pressure, when you let that stuff move, you start to look at the hydrodynamics of it. Now we're looking at crustal solid dynamics. It can make large extinct cracks start moving again, because I believe there was a lot of movement this way at an earlier time, which would account for the Appalachians, compared to just now it's moving this way. But it was moving faster back in prehistoric times when there was more carbon dioxide in the atmosphere, so things were really shaking, rocking, and rolling here on planet Earth. So much that, for example, super huge amounts of hail, yards and yards of it, would fall in an hour on the southwest, cut the mesas, and also assist in cutting the Grand Canyon. So you look at the geology of the Earth and you can start to see increased huge weather systems that have created its landscape. You look at the southwest of the Americas and say, how did that happen? Well, it probably was hail, an incredible amount of it, measured in yards per hour. So